Welcome friends. We shall see shortly the how power circle diagram can be obtained using graphical approach. It is a completely graphical way of doing it. So we have 3 steps to follow: 1, 2, 3. So if you follow these steps, you can obtain the entire power circle diagram. So let us start. We have graphical method. Now to start with, Vs. Vs is equal to AVR plus BIR. What is VR? VR is equal to, it is the magnitude of VR and angle 0 because it is a reference phasor. What is IR? Its magnitude is IR and it should be lagging by some angle phi r, which is called lagging power factor angle. Current is lagging. What is A? It should be A magnitude and it should be contribute an angle alpha. What is B? Sorry, I have made a mistake. It should be B into IR. So it should be B magnitude at an angle of beta. So practical value of beta is around 75 to 85 degree. And what is Vs? It is Vs magnitude angle delta, which is called load angle. So let us now first try to represent. Let us first try to represent this equation in terms of phasor diagram. That is Vs is equal to AVR plus BIR. We should represent this equation in terms of phasor diagram. So this is my step 1. This is my step 1. What is step 1? Representing this equation Vs is equal to AVR plus BIR in phasor diagram. So let's do that. Now we have VR as our reference phasor. Okay, we have VR as our reference phasor. It is making an angle 0. So now if this is a phasor, now if it is multiplied with x, let us say this is x, suppose this is multiplied with y, so it should be yx, provided y should contribute an angle theta. So y should be contributing an angle of theta. So if this y phasor is contributing an angle of theta, so that x is multiplied by y, then yx should be directed along this direction. So the phasor x should be rotated by an angle of theta in counterclockwise direction, that is positive direction. So in this direction, counterclockwise direction. So in this way, if VR is multiplied with A, A is contributing an angle of alpha, that is positive angle. So that AVR should be made a rotation by an angle of alpha. So this should be AVR. This should be AVR and this angle essentially alpha. This should be AVR and this angle is alpha. So even before that, for the clarity of the drawing, I may please represent the the axis. Okay, so an imaginary axis we may consider here. Okay, so if this is if this is a VR, if this is VR is the reference, so a VR should be ahead of VR with an angle of alpha that is contributed by this phasor A. Now what is IR? IR should be lagging by an angle of phi r. IR should be lagging by an angle of phi r. So this is phi r. Now BIR, similarly, if IR should be multiplied with B, then this IR should be rotated by an angle of beta that is contributed by this B. I repeat, if this is IR, then if you multiply this B phasor with this IR, so the angle contributed by B is beta, so BIR should be in this direction, BIR should be in this direction, so this angle is beta, which is a positive angle that is contributed by this phasor B. So now we use an approximation. Now see, practical value of beta is 75 to 85 degree, but for the clarity of the drawing we use beta equal to 90 degree. We use beta equal to 90 degree for the clarity of the drawing, for better understanding of the drawing. We should use beta equal to 90 degree. So if we use beta equal to 90 degree, then if you drop a perpendicular, so if you drop a perpendicular on IR, right, like this, so this should be the BIR phasor for you. This should be the BIR phasor for you. This is 90 degree, or you can say this is beta. We can use beta as equal to 90 degree for the better understanding of the drawing or clarity of the drawing. Now the phasor summation of AVR plus BIR, that is equal to VS. AVR plus BIR, that is equal to VS. So this represents the phasor summation or phasor representation of this equation. VS is equal to AVR plus BIR. So the angle between VS and VR, the angle between VS and VR is called delta. It's called load angle. This angle is delta. This entire angle is beta, because I told you beta is equal to 90 degree. So essentially this angle is this angle is beta minus delta, right? This angle is beta minus delta, and this whole angle is beta minus alpha. So this is the step 1 for you. VS is equal to AVR plus BIR. Now with continuation with this, we have, now what is our main objective? We want to plot power circle diagram. So we should have power quantities. We should deal with power quantities, but this equation has a voltage equation. Okay, VS is equal to AVR plus BIR. This equation is a voltage equation. So somehow we need to convert this voltage equation, VS is equal to AVR plus BIR, this equation into a power equation. We need to multiply this equation with something to get a power equation. That means we should deal with all quantities that is either power or that has a dimension of power. Okay, so that is be done, or that can be achieved by if we multiply this equation with VR by B. If we multiply this with VR by B, then what happens is that it will modified as A by B VR square plus BIR into VR by B. So that is equal to, so the equation comes out to be Vs VR by B, that is A by B VR square plus VR IR. So now we have a power equation. We have a power equation. We have VR IR, which is a power. We have A by B VR square, which is also a power dimension, and we also have Vs VR by B, which is also a power dimension. So this equation has a power dimension. Now what is the basic difference between this equation? Vs is equal to, what is the basic difference between this equation and this equation? Okay, even before that I have forgot one thing, that I must draw another, another axis, all imaginary axis. This angle should be phi r. This angle should be phi r. So let me name them. This is x, this is y, this point is origin is O, and let me point x dash, y dash, and this point is O dash. So now coming back to my second step, step number 2. What is the basic difference between this equation and this voltage equation? Now you see this voltage equation has been multiplied with VR by B. Now let me check what is the net angle, what is the net angle contribution, what is the net angle contribution of VR by B. That thing we need to check. So in order to check that, you see VR is contributing 0 and B is contributing beta. So as a whole, if you multiply this, it will be contributing a net angle rotation by an angle of minus beta, that is minus 90 degree. That means if you multiply these three quantities, that is Vs, that means you multiply this with BIR, and if you multiply it with AVR, so this entire assembly will be shifted or will be rotated by an angle of 90 degree in this direction. Why 90 degree? Because I told you, you consider beta equal to 90 degree for the sake of clarity, for the better understanding. Now why in this direction? Because it is contributing minus beta, which is contributing minus beta. So minus beta means clockwise direction. Minus beta means clockwise direction. So in the next step, what we shall see, that this entire assembly will be rotated by an angle of 90 degree. So let me rotate this entire diagram by an angle 90 degree one by one. So let me first draw the x dash y dash axis. So we have first x dash axis here. We have first x dash axis here and y dash axis here. This is y dash and this is x dash and this is dash, right? So this is, you see, this was x dash. So if it is rotated by a 90 degree clockwise direction, so the new direction of x dash will be in this direction, vertically downward. So here it is vertically downward. So if y dash is this, if it is rotated by an angle of in clockwise direction 90 degree, now new direction of the y dash is this. So you see it is horizontally in the right direction. Okay. Similarly, this axis xo y dash should be located accordingly in this way. So it should be, this is x, this is y, and it should be the origin, right? Now the line joining between O dash to O, which was AVR, now in this case it will be O dash to O, this will be A by B VR square. This should be A by B VR square. Okay. Now we have a load line like this. Sorry. Let me draw it more clearly. This is y, this is x, this is what. So this should be A by B VR square. A by B VR square. Now it should be now next step. Now BIR is replaced by VRIR. What that should be the load line for us. So this is VRIR. It should be VRIR. And now see, for the with reference to the previous diagram, it is the y to BIR. It is phi IR. It is the angle between y-axis, this y-axis, and this BIR phasor. It's the angle. It's phi R, right? So in this diagram, it is the angle between y and VRIR. It's called phi R. And this summation of these two will be VS VR by B. VS VR by B. So let me figure out these angles. So this angle should be delta, because this is the angle between VS and VR. Actually it was VR, so now according to the diagram it should be VR square by B, although it is not required, but still I am writing. So it is the angle between VS and VR, it's delta. Now angle between this shift, it's small angle, this is alpha. Now this entire angle is beta, so this much is beta minus delta, and this much is beta minus alpha. Now with this diagram, we have only one problem. What is that problem? Let me draw it once again. Let me show you the required problem. Let us say this is xy, this is O. Let us say we have a load line like this, we have a phi R. So now up to this, it is PR, which is equal to VR IR cos phi R. However, the reactive power component is QR, this value, which is equal to VR IR cos sin phi R, which is getting as a negative number, So due for inductive load, QR should always be positive. So that is the only one problem with this diagram. For capacitive load, we may get QR as a negative, so it can generate leading bar. But for inductive load, QR should always be positive. So it is indicating the lagging bar. So this is the only one problem with this entire diagram. So how it can be modified, that is step 3 for us. That is the step 3 for us. Now if somehow we can rotate this diagram. If somehow we can rotate this diagram by an angle of 180 degree. By an angle of 180 degree, if we can rotate, then this problem will be solved. So let us do that. So this axis is y dash, x dash, o dash, and this axis is y, x, o. So now it should be a by b VR square. It should be VR IR, and it should be VS VR by B. So this represents the radius. So it will trace the locus of the circle like this. Will trace the locus of the circle like this. And VR IR, if this is phi r, so PR is positive. You are also getting positive. So this is the complete diagram for your receiving end power circle diagram. Let me draw it afresh once again. So this is one axis. We have another axis like this. So we have, this is a by b VR square, a by b VR square. This should be my load line VR IR, and this should be my radius VS VR by B. This angle should be beta minus alpha. So this happens to be the center of the circle, which is x coordinate will be minus a by b VR square cos beta minus alpha. This is the x coordinate, and y coordinate should be the same value with a sign, minus a by b VR square sine beta minus alpha. So this is the center for you. This is VR IR, which is called load line, and this is power factor angle phi r. So this is, and this diagram or this trace of locus is the locus of the circle. So this is your receiving end power circle diagram, and we are getting this by graphical method. So in step 1, we have represented Vs is equal to AVR plus BIR in terms of phasor diagram. And thereafter, we have multiplied the entire equation with a term VR by B. We multiplied the entire term with VR by B so that we can get the power equation. We can get a power equation. So in doing so, the entire diagram, as mentioned in step 1, okay, as mentioned in step 1, is rotated by an angle of 90 degree. Okay, by an angle of 90 degree in clockwise direction. That means the negative rotation by an angle of 90 degree. So with this only one problem persists. We see that in doing so, we are getting QR as a negative. That is a problematic, because for lagging bar, for inductive load, QR never be negative. So in modification, doing so, we we flip the entire diagram with respect to this horizontal axis, so that this diagram is coming. So we have radius of the circle Vs Vr by b. We have Vs Vr by b, radius of the circle. We have center of the circle located on the third quadrant. That means it is your actual, it is your actual axis. It is your x, it is your y, and it is your origin. So with respect to this axis, you have your center located on the third quadrant, and you have a radius Vs Vr by b, and this is Vr IR represents the load line. It working at an angle of phi r, which is called load power factor angle. So with this, I am ending this lecture here. In the next lecture, we shall demonstrate a numerical problem on this power circle diagram. Thank you.